Good morning, Emilio Garcia here, teacher of physics and chemistry of SEC Dublin International School here in Ireland. Today we're gonna introduce briefly what is organic chemistry. The definition is very easy, it's very simple. You just need to know that organic chemistry is a branch of chemistry, okay, that study the structure, properties and reactions of organic compounds. Now here is the key word, organic. When we talk about organic compounds, organic involves the use of carbon. Okay. For this matter, we're gonna just work with. Let's first of all let's introduce this properly as it deserves. So let's put organic chemistry. Okay, and let's put here organic chemistry is the study of organic compounds. Organic compounds needs carbon. Okay, so everything is going to be through carbons, specifically hydrocarbons. Okay, what is a hydrocarbon? Let's put here hydrocarbon. What is a hydrocarbon? Hydrocarbon is when we bond together the two chemical compounds that are hydrogen and carbon. Okay, how we're going to put them together? Let's go with this. Organic chemistry, hydrocarbons. So the first thing we need to do is, for example, we need to say that for every carbon, we can single bond, in this case, single bond, because we're going to work with alkanes, one hydrogen. Okay, so how can we do this? Let's say for every carbon, we said that we can bond single bond, four hydrogens. In this case, as you can see, we need to check how we have one carbon and four hydrogens. What did I mean when I said single bond? Single bond is just a single bond structure. In this case, as you can see here, I'm going to put it in another color so you can see it clear. This one here is a single bond. As you can see, it's just one. We represent it with one line connecting the carbon to the hydrogen. In this case, you will have one carbon and four hydrogens. This is single bonds. That's why we are working with alkanes. Remember this suffix, anes, okay? If we put ines, then we will need to do a double bonding, but we are not there yet, okay? So let's express this in a very simple way, okay? How? With the nomenclature. There is so many different ways that we can name a compound. That's what we call nomenclature. The nomenclature, it all comes given by the UPAC. It's very good if you just go to the web page. They have plenty of information about chemistry, plenty. And it's always, from time to time, keep up to date and see this page. So nomenclature, what is a nomenclature? A nomenclature is the way we name a compound. There is a lot of representation of a compound. If we see, for example, let's make it one very, very simple. If I have one carbon with four hydrogen, then in this particular case, this is a representation. So we have the first representation. Now we're going to name it. Okay, we can name it as this one is specifically is methane. Methane. Okay, it's a gas, and is the combustion is the mixture of carbon and hydrogen. One single carbon single bonded with hydrogen. That's methane. Okay, methane. Remember this suffix. If you want to know more about this, okay, you just need to mix oranges and bread and eat it. The result will be methane. It's a gas. Okay. I don't want to be gross, but let me continue with this. Another representation of this will be 1C. For every carbon, we will need to count. In this case, we have four hydrogens. So this will have the first compound of hydrocarbon, methane. One carbon, four hydrogen. Let's go to the next level. Let's say we are going to bond two carbons. Well, in this particular case, we will have here, let's represent first the two carbons, and then we need to bond them together. We know that for every carbon, we have four single bonds. So let's put it in another color so we can see this clear more, this example. In this particular case, we have, let's join them together, and then we have the first one, This first carbon already has the 4 single bonded, and this second carbon now already have the second single bonded. Can they share one? Yes, and they are completed. So in this case, now I give the hydrogens, as you can see, and then I can represent this in this particular way. How? Well, let's see if I can just change the color. If I can just put, see how many of them, how many carbons? 2. Very good. Remember, this part here is called the subscript. Okay, just in case you don't know, subscript, and the upper part is the superscript. The upper part, we just use it to count the electrons, but this is a different thing. Okay, we're doing something different here. This is organic chemistry. Remember, it's the branch of chemistry that treats the structural properties and reactions of organic compounds. Okay, so going back to the topic, we have 2 carbons here. Very good, 2 carbons, so we represent with number 2 in the subscript. How many hydrogens? Let's write the hydrogens and let's count them. 1, 2, 3, 4, 5, 6. So 6, I have it here. And then the nomenclature. How we call this one? This one is exactly ethane. Okay, this is ethane. Remember, ane. Why? Single bonded. If you see this, this means single bonded. Okay, let's go to the next level. Let's try to make it bigger. So let me delete all this so you can see it clear. Okay, and let's try to work with 3 carbons, then 4, then 5, then 6. Then why change the names? We'll see this. So for example, if we're going to work with another carbon, that is 3 of them, 1, 2, and 3. Just remember, I can change the order. I can put this carbon, for example, here. Will it make a difference? Or I can put them here. It wouldn't make any difference. I can put it here. So let's see. We have the 3 carbons. Very good. So carbon 3 so far. Now, we said for every carbon, we can put 4 single bonding. So let's start bonding together. Now, the first thing is connect them. Did I connect them? Very good. Now, this carbon can have 4 bonding. So we have one here, we have another one here, another one here, and here. So this one, if you count them, 1, 2, 3, 4. In this case, this one is taken by another carbon, so I cannot give a nitrogen. So we have 3 hydrogens. This one, I have 2 of them taken by carbon, so I can just give 2 hydrogens, and it completes the 4 single bonding. And in this one again, I can have 3. And if you pay attention here, this is what I want you to see. For every hydrogen, you must have 4 single bonding. In this case, you have, let's say with this one, you have 1 here, 2, 3, and this one is the 4th. Very good. Now, so we connect the second one we have here. 1, 2, 3, and we are sharing the 4. Very good, no problem. So this one is the second, so we can give this one the 1, 2, 3, and 4. And as you can see, all of them are 4 single bondings. Very good. Now I put the name, of, I count the number of hydrogens. How many hydrogens do I have here? 1, 2, 3, 4, 5, 6, 7, 8. Very good. So let's name it. This one, it will be propane. Remember ane. What means this suffix? This means single bond, single bonding. Okay, that's what this means, single bonding. So that's why it's propane. This is propane. We see it clear. Let's go with the last one. The last one of the first 4 that they have their own name. Okay, that's what it is. That's what it is. In this particular case, we will have 1, 2, 3, and 4. You can pause the video now and you can try it yourself. This is very easy. Okay, once you understand it, this is very easy, very simple. At least this introduction. So we can just start with the bonds. I'm going to change the color for the bondings so we can see it clear. So let's connect them first. So we have the bonding. Now this one, because it's in the extreme, usually they have three because the other one is taken. So one, two, and three. Very good. This is taken by a C. So one, two, three, four. So it's only space for two. This one is only space for two again. And this one you have space for three again. Very good. So we start counting. We start counting. How many C's we have? Four. And how many hydrogens? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So hydrogen 10. Remember to write this in the subscript. Subscript is the lower part. What is the name of this one? This is butane. Ane. Remember, ane is single bond because we are working here with alkanes. Alkanes. Anes. You can see means single bond. Very good. Very good. So we have the first four. We have the first four, and we are going to write them together so we can see, and then we're going to see a different type of representation. Okay, so the first one, it will be CH. How many? How many? Four. Very good. And this will be the name of methane. Methane. Different way of writing it. We can put C with the four bondings here. This is very simple. Then the second one we have is C2H. How many H? We will see it here once we connect them. We can put here. Let me just write this a little bit more clear so we can put, let's put the name first. Okay. C2, the name, it will be ethane. Ethane, and ethane will be two of them. So we can put here three. We can put here three. So it will be how many hydrogens? How many hydrogens? Let's see this clear. Six. So H6. And we have methane, ethane. Let's continue with propane. Propane is C3. How many hydrogens? Well, we need to count them, right? So let's make it propane. Let's make one, two, three. So three. Let's remember we have hydrogen chains here. Single bonded. Forgot this one. And let's count them. 3, 6, 8. So propane is 8. And the last one with its own name. Okay, the next one comes all from Latin. It's very simple. The next one is C4H10. What? But we need to count them first. So let's make 1, 2, 3, 4. As you can see, I can write all in one line, or I can write it in two lines. Won't make a difference. It's all to make more space if you want. So let's make it. Let's make it like this. And here we have it. The name of this one is butane. Very good. There is another way of writing this, okay? So just so you know that we're going to make it in color red because this is a lot of CH, a lot of, and it can be a bit messy. That's what I think. So that's why we can make two C's in a line like this. These three C's in 1, 2, 3. This butane 4. 1, 2, 3, 4. And you will be like, what is this exactly? What are these lines? I don't get it. Can it be like this? Can I just change this to this? Yes, you can. Yes, you can. And I'm going to tell you why this is more simple. This system is more simple. I like by lines. I like it by lines to represent everything because I can see it clear. If you see a line, for every dot where begins and end the line, you have one carbon. In this case, you can see, I'm going to put it in green. Look, one carbon and another carbon. How many carbons do I have here? Two. Very good. So it's ethane. In this one, 1, 2, and 3. In this one, 2, 3, 4. So I know exactly. And if you continue watching, okay, you can see how I can give them the hydrogens. You see, still this is a bond. You can see how I can give them the hydrogens. I can write this in a more simple way. If I start removing all these hydrogens that I'm writing here, so just so you know, if I start removing them, but not to make it messy with a lot of H and a lot of C's, we can see all this very simple way of writing this way of organic chemistry. This is the most common use, okay? This way is the most common use, and you will see it. How I can just convert to lines. Let's make it again. Let's put it in red. In this case, I only have one C, so there's no possibility of line. What am I going to write? A point. It's no option. So in this case, I can just put the C. But this is enough. I can see for every carbon, I have 4 bonding, so you know it. But for the other ones, I can put 2 lines. One line in this case, 1, 2, 3, 4 carbons. 1, 2, 3, 4. And if you see this, you will recognize doing this that you can start counting the carbons. 1, 2, 3, 4. 1, 2, 3. 1, 2. And you know exactly what it is. You know exactly what it is. What happens when we have more than 4? Okay, what happens if, let's say, if I have 5 carbons, 6, 7, 8, 9, 10, 11, it doesn't matter the number. We're going to say this. Let me just remove all this. What happens when we have more than 4 carbons? Well, we know that the first 4 has their own name. Okay, the first 4, they have their own name, like methane, ethane, propane, and butane. That's forever. Okay, if you see one carbon, it's going to be always methane. Okay, but what after 4, after the butane, we have more. Like, let's say, for example, here, let's write it in blue. Let's say 5 carbons. 1, 2, 3, 4, and 5. We all know how to mix this, right? We learned it before 1 minute ago, and we all already know how to give the single bonding. So first we give the bonding here, and now that it is giving the bond, now we know how many bonds we can give to all of them. We know how many bonds because they must complete 4. So in this case, we're working with hydrocarbons. Remember that hydrocarbons, organic chemistry. Then it will come the functional groups like alcohols, but not yet. Let's go slowly. So we have here 5 carbons. So C5. Let's make it in another color that we can see it clear. Okay, not to mix them. Put it in black. C5, and then we count the hydrogens. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, nomenclature. Here comes the point. We said the first 4 have their own name, but after that, it all comes from Latin. In this particular case, 5 in Latin is penta. Okay, so we are gonna call him pentane. Remember, ane. Why? Because it's single bonding. Single bonding. Pentane, single bonding. Ane. Okay, why? You see one bond only, so that's it. Single bonded. If it will be 2 of them, then they will change everything because it will be pentene, but it will not be an alkane. It will be an alkene. Okay, but forget about that. Not yet. Okay, not yet. We are not there yet. So let's forget about that. We are with the alkanes now. So let me correct this and let's put one single bond. In this case, H. Do we have this clear? Yes. This one. Which will be this one? Let's name it. This will be pentane. Okay, Don Emilio, so what happens if we put 6 carbons? Okay, let's make it. Let's make it 6. You can make all you want. 1, 2, 3, 4, 5, and 6. Now we know how to bond them together. And it will be, first of all, we bond them together, single bond them together, then we give them the hydrogens to complete 4. In this case, you see this one has 4. This one has 4 as well. 1, 2, 3, 4. All of them complete their own 4. And then we name it. We name it. So we said that it's going to be everything in Latin after 4. So 5 is pentane. So 6 is hexane. Very good. Remember the suffix ane. So x, pent. Pent is 5, x is 6, ept is 7, oct is 8. But we know a way simple method of writing this without all the C and H's, right? Because this is a bit messy. So how is this? Pentane, 5, 1, 2, 3, 4, 5. This is pentane. Hexane, 1, 2, 3, 4, 5, 6. Then I have hexane. Let's make it again more clear. Let's make it again more clear. Don't worry. Look how many carbons. 1, 2, 3, 4, and 5. And this I have 1, 2, 3, 4, 5, and 6. If you want, you can still give them the hydrogens, you see, but it will make it messy again, like this one. So it's better if I just leave it like the simple game of lines, okay? This is a very, very brief introduction. This is a very, very brief introduction. Then you have longest chain, you will have to do more things. But so far, you know what we're working with. Hydrocarbons, hydrogen, carbon, okay? Organic chemistry, the branch of chemistry is one of them. Chemistry has a lot of branches. One of them is inorganic, but in this particular case, is organic chemistry. Structures, properties, reactions of organic compounds. If it's organic, remember, if it's organic, it contains carbon. Okay, so just let me finish with this. 1, 2, 3, 4, 5. Hexane. 1, 2, 3, 4, 5, 6. Hexane, pentane, octane, all of them that you want, okay? So to finish, okay, let's make it simple. To finish, let's start working with an example that the first 4 is, let's make it is methane, ethane, propane, and butane. After that, these are the first ones. This has their own name, okay? Let's put this clear that they have, let's put the symbol, and let's put their own name. Only the first 4. After that, it's the use of Latin. After this, we use Latin. Example, penthane, hexane, heptane, we have octane, and just remember to finish this class, just remember ane means single bond, okay, and pent means the number of carbons, in this case pentane, so 5C. Then you represent it, and then you know the number of this. I hope you enjoyed this class. If you have any question, just please contact me. I will go further, and this is the first group only. Okay, this is the first thing is alkanes. Okay, single bonding hydrogens and carbon structures name hydrocarbons. Organic chemistry, the branch of chemistry that works with organic compounds. Organic compounds, carbons. Easy as that. I hope you enjoyed this. Thank you very much. Like and subscribe. I love to say this. Thank you.